Ladies and gentlemen, let's talk about atoms. And in particular, we're going to focus on the history of the subatomic particles of atoms, and then we'll break down those subatomic particles. So, our learning objective is to break down the atom and be able to describe the three subatomic particles that are inside an atom. And that means being able to describe where it's at, its location, its charge, its mass, and why it's important. I want to remind you that in the 1800s and 1900s, there were scientists that were starting to see observations that allowed us to understand that there must be things inside the atom. J.J. Thomson was playing with cathode ray tubes and found that he could bend the path of the ray by using electrical charges on the outside of the tube. And what he found was that the ray always bent towards a positive charge. Now, they knew that opposites attract. So whatever this was that was inside this matter, it must be negatively charged because it's going towards the positive. So he hypothesized that something inside matter must be negatively charged, and he called these electrons. Now, a few years later, Rutherford was playing with alpha particles and shooting them at matter. And in his famous experiment called the gold foil experiment, Rutherford shot alpha particles at a thin piece of gold foil. And if the atom really looked the way Thomson thought, then he expected the particles to go right through the atom. And so all of the particles would go through, and that's what they expected. But what actually happened was some of them got deflected. And what this meant was that there must be an area inside the atom that has a really large positive charge, that it's able to push away the positive alpha particle coming in, because like charges repel each other. That means to push away from each other. And so he noticed that there was a little bit of scattering every now and then. Now, most of the particles still went right through. So he hypothesized that the atom is mostly empty space, but there's a positive nucleus in the middle. And he said that the nucleus must be positive, and he called those positive charges protons. Now, the later discovery of our third subatomic particle, called a neutron, came not until the 1930s. And at this time, scientists began to develop new techniques to study matter, and one of them was mass spectrometry. And that is using magnets to push atoms as they go through a tube. And if you think about a bowling ball versus a soccer ball, I can kick a soccer ball a lot further and push it easier than a bowling ball because it weighs less. And in the same way, this magnet can push on atoms, and depending on how much they weigh, they will move different amounts. And what was amazing at the time is that scientists were looking at pure elements and putting them through this machine, and they were noticing that different atoms had different masses. This was new because we thought that atoms were all the same of an element, but it turns out that they're not. So something inside an atom makes its mass different. It didn't have a charge, it was just mass. And they called these neutral particles, neutral means no charge, neutrons. And so this is how we understand a little bit about the atom, the electrons, the protons, and the neutrons, by doing these experiments. And now we can start thinking about how that information can be used to help us understand all other matter and how we catalog this information.